My name is Michael Carducci. I'm going to be your moderator tonight for the panel, and I'm really excited to be here because it's an exciting time in the development of the Gradle ecosystem, what people are doing with it, and really what's happening right now. This is a tremendous opportunity for you to ask the questions that you have, because the great thing I've seen so far today is so many people are using this technology in different ways, and it's growing, it's evolving. And I know you've got questions that have come up during the sessions today, questions that have come up in your places of work. So this is your opportunity to address these to our panel of experts. If you have a question, if you would, please just kind of make your way up to where the projector is here, and I can come out, we can address these one by one. I want to keep this quick. And so I'm not going to bother asking the panelists my questions because I know you're more interested in your questions. So while we have our first question kind of come up to the projector there, would you mind taking a moment and just introducing yourself down the line, who you are and what you do?
Sure. Yeah, I'll go first. Thanks, Michael. My name is Luke. I work mostly on Gradle Enterprise at Gradle. Yeah,
my name is Hans Doctor. I'm the CEO of Gradle Inc. and the founder of Gradle.
I'm Stefan Oehme, and I lead the performance team at Gradle.
So I'm Cédric Champeau, and I'm working also in the performance team at Gradle.
My name is Eric Wendlin, and I lead the Build Tool core team at Gradle.
And I'm Daz DeBoer. I'm a crusty old developer at Gradle.
All right.
Good old developer.
he's still around for some reason.
Who'd like to ask the first question? If you feel shy, I'll come to you. Otherwise, it's going to be a super short panel discussion, and we'll be right back on track for the rest of the day.
The bar doesn't open until questions are asked.
That's true. Oh, right. Thank you very much. Oh, we got one right up here. That's okay. And then I'll make my way down there. Spencer, please.
So, Project Jigsaw, anytime soon?
Pepper, come here. So Gradle 4.1, the milestone 1, you can already run on Jigsaw. So it is a huge improvement compared to what we had. So just for history, I think when Gradle 3.0 was out, it was compatible with that version of Jigsaw that was out at the same time. And then they changed the APIs and everything was broken again. So we decided just to park that work until the API was stable. So that's what we've basically done recently. So make sure that Gradle runs on Jigsaw, and then in the future we're going to provide APIs to build modules. So in the meantime, you're going to have a new guide written by Pepper, and a guide explaining exactly how you can build modules, run tests, etc. with Gradle and Jigsaw.
And we've got another question here from Martin.
Hello, my name is Martin, and I work in hardware development. And my question is, we've taken the Gradle training, and it was fantastic. We learned how to write plugins the traditional way, but what we would really, really like to learn is how to write plugins using the software model, the DSL. Is there, and I have another question after that. So anyway, my question is there training for learning how to write plugins using the model DSL?
Yeah. So I take this one. So there is an effort underway right now, led by Adam and Adam. You here? And Daniel. So we decided that we backport the model DSL to the current configuration model, right? And so that we unify the platforms. So that is and extend it when necessary, right? So that is an effort, and we definitely plan to have a dedicated native training for how to write extensions then for this platform. So Daniel, do you want to talk a little bit about that? I think you give a presentation on that tomorrow as well, right?
Yes, exactly. So tomorrow I'll be explaining a little bit what's the future of native. But basically, as Anne said, on the GVM side, all the model part was backported to the current models. We're talking about the variant-aware dependency and also the API versus the implementation. All that was backported on the current model, but for a software model, we're looking into backporting even more onto the software model to bridge the gap between the two, so that people with knowledge of the current model can be able to go and migrate for their native on the current model, on the software model. So really, it's really about, as Anne said, there's some work ongoing there. The main point there is really about the configuration, that the execution will stay the same, everything will going to stay the same. It's really about the configuration that's going to be, that will change a little bit, but it's all for the best. So I really encourage you guys, if you want to know more, the talk tomorrow at, I think, for the last slot of the day, come in and we'll talk about that.
Yeah, okay, sorry.
And also, we have also on the Slack channel, so you can just join in. There's a hashtag native, so if you want to talk about this, we can go and talk about more there.
Yeah, so native is very important to us, just to make that clear. And because of that, and we have developed so much functionality now in the current model, like the variant-aware dependency management Adam presented in the keynote, right? And the native model has its own dependency management, right? We really felt the pain, right? And also exactly what you have said, hey, we feel like we can't use the normal resources that we find on Gradle when we're doing native, especially when we want to do extensions, right? So the future, I'm super excited about that, right? That we can consolidate that, and that we have one dependency management engine, that we have one way of caching build output. That is another thing that will come for native in Q3 probably, that the output of the native tasks are cacheable. So yeah, that's the short answer. Or not so short answer.
And to keep everything moving, I wanted to open the floor to another question. Oh, right over here. We got two. All right, we'll line them right up.
Hello. This question regards the configuration phase. I saw in a blog post that was quite long ago that there was an idea of making it parallel. And I would like to know whether there is a plan to make it parallel and when.
So not at this point. The idea is there, but there's way more low-hanging fruit that might make that a long time off. So when we're looking at really big projects, they have configuration times of maybe 5 seconds. So we have an example project actually in our performance testing that has 500 modules, and it applies only well-behaved plugins, and its configuration time is below 1 second. So that's like, if your plugins are well-behaved, it's already pretty damn fast. Which is, for that project, also partly due to that the Java plugin doesn't create that huge amount of tasks. When you look at the Android plugin, which creates a huge amount of tasks per project, it's more. But we have a list of very low-hanging fruit that we can collect to make task creation cheaper, which is one of the dominating factors of configuration time. So if you look at these projects that take like 5 seconds to configure, for instance, we could easily get them down to something like 1 second or even below that. At which point it really becomes questionable whether we need to parallelize that.
In the case of, I don't know, the continuous use case, Gradle continuous, if you have 1 second, is quite, well, just, I agree there are, but 1 second maybe could be, for instance, Bazel or Buck, they go faster than 1 second. So
yes, but we're only talking about the top end of projects, the biggest you can find. And there's still stuff to improve, like moving from dynamic Groovy build scripts to Kotlin build scripts, which will lower that again, because all that, call site mechanism that's creating all these temporary arrays to pass parameters disappears if you have a statically typed language for your build script. So I mean, if you have lots of sub-projects, you probably have lots of build scripts. So that will reduce that again. So I'm not yet convinced that we will need parallel configuration soon. Although, in the long term, it of course makes sense to enforce isolated projects that don't reach into each other, to do configuration in parallel, and also to do a proper implementation of configure on demand. But that also requires some new ways to cross-configure things, because if you say you can't reach into your sub-projects, for instance, then you need to provide better ways to do that kind of stuff. So that's more effort, and it requires collaboration from all plugin authors, and users need to learn new things. So I think it's much more important to collect all those other low-hanging fruit that we still have in configuration time, and then reevaluate. And if you have long configuration times, then please send us those profiler snapshots. We would be very interested to see what your builds are suffering from.
Yeah.
I'll talk about that in my talk tomorrow too.
And I can just add, there is a way that you'll be able to get configuration in parallel in Gradle 4.2, which will be to use composite builds. So composite builds is a way of composing multiple builds into a single whole, but they're inherently decoupled. So it's really simple for us to run those configurations in parallel. Unfortunately, the price you pay is that the cross configuration of all your builds is more complicated. You have to extract your build logic into a separate plugin and apply that plugin to all of those builds. But that is a way that you can now, or very soon, will be able to get configuration in parallel in a composite.
Yeah, so I think the key thing of what you said is, right, we want first do the improvements that work out of the box for everyone. Things are just faster without doing anything. If you naively parallelize configuration, the problem that you will see, if you look at the Gradle build, right, and at the build scan, I don't know, 80-90% of the configuration time is the root build script. So even if we configure in parallel all the sub-projects, the benefit, there will be some benefit, but not what you would expect because of configuration injection from root into sub-project. So that is why it's so important. First, we want to do everything that is possible, where people don't need to, that just works, because to make, as you said, right, to make a parallel configuration really effective, we want to decouple projects more from each other. But that is a change that then also requires refactoring on your side. It is there, as you said, there are many benefits for that. We want to get there, but first let's do the simple stuff, and then let's see how much, with what urgency we need to push that. Right. So that's how we, I think, very successfully made performance progress, right, over the last 12 months. Not speculating too much, just first improve the implementation and see how much you can push it, and then think about where do we need redesign after you see the numbers, right? So that's the answer.
Thanks a lot.
But maybe the last point is, I would say for 98% of the projects, after those improvements, we hope the configuration time is 100, 200 milliseconds, right? So, and not 1 second.
So I apologize in advance for bringing us from the sublime to the mundane. Do we think that this will be the year that the Maven Publish plugin comes out of incubation? I gotta ask it. I just had to. Sorry, guys. I do have another question if you just want to blow right by that one. Going once.
So, yeah, I mean, it's kind of ridiculous, right? I saw this tweet like saying since 2000, I don't know, 13, the guy looked it up, right? We have those two mechanisms. It depends on our priorities, right? So, I mean, what would you have preferred? Let's say build cache, right, and worker API versus. So I fully appreciate, right, that we want to get rid of this kind of messy situation. At the same time, if there's gold to give to the community, high impact features, right? So it's a priority discussion. The goal is, our goal was to unincubate it this year, but it's not scheduled, so that's why I don't promise anything, right? I say this is scheduled, this is a strong statement. This is not scheduled, but we hope we can unincubate it.
Yeah, I do think of the minutes from your keynote this morning, the minutes that people are wasting or spending, trying to reconcile all this. But anyway,
point taken.
And if anybody else wants things, that's also fine. But I actually do have a somewhat deeper question here. Just talking in terms of IDEs and the great integration that's been growing through the tooling API with like IntelliJ, BuildShip. Looking out over the coming year and possibly years, do you see us getting the ability to do a little more customization, interposing on the tooling API, sort of the way we can do when we do Gradle IDEA, right? When we can change the XML and all that, will we have the ability to sort of influence the IDE through the tooling API going forward?
You already can. So
Cool.
Buildship will take the whole Eclipse model into account.
Okay.
It's the same, like what the tooling API ships to Buildship and what we use to generate the XML is exactly the same stuff.
What about an idea?
A subset is respected. So maybe Nikita wants to chime in? No? Okay. So IDEA currently respects a subset of those settings that are in the IDEA model. And we definitely want to work with JetBrains to get more of that stuff into IDEA. And also, we want to know from JetBrains, hey guys, what's the modern way to generate an IDEA module? Because the IDEA plugin was written when, like 8 years ago. Things have changed. IDEA has gotten cooler features, so maybe we can benefit from them. So yeah, so Eclipse already does it, and IDEA will get there.
Thank you.
And we've got a question in the back. The really great thing about this is it allows me to get my steps in every single day. So now this is good. This is the only exercise I get.
My question is about code reuse in build logic. So the two ways that I know about, at least for easy code reuse in Gradle, are to write a plugin or to put your build logic in a file and then use apply from to access it in multiple places. And the former, writing a plugin, sometimes feels a little heavyweight to me. And the latter, I think, can sometimes feel a little bit clunky just because it can be unintuitive to really figure out how the logic is being applied or where it lives. And I was wondering if you think that, if you would agree with this, or if I'm just looking at this completely wrong and I'm missing something here. I don't know if there's an idea for something like mix-ins or some sort of classes that are used in Gradle or anything like that. Just looking to get your thoughts on it.
I'm not sure I understand the question fully. So, so you have script plugins. You have the build source project, where you can write plugins for your project, and then you can write completely separate plugins. So you're saying build source is already too complicated, or script plugins too messy?
I think what I'm saying is that sometimes writing a plugin feels like it's kind of going like a step too far to get some Gradle logic that I only want to use within a single project. And so if I don't need to share logic across different Gradle projects, I just don't want to reuse code within the same project. The fact that the only option is, or at least the only option that I know of, and I'm not super experienced with Gradle, is to use apply from. It's
not the only option. You have the build
it's not,
source.
okay.
You have the build source project where you can put plugins.
Okay.
Yeah, and also with composite builds, you can just compose a project with another project that provides plugins just in the same repository. So, like, basically, the build source project will become less special. It will just become an included build. But yeah, so right now there's a project. It's called build source. When you can put your plugins in there, so you can just write a simple plugin. You can use compile static Groovy to keep the syntax very, very close to what you see in your build scripts. And then when we switch to Kotlin, you can take your Kotlin code and paste it into the plugin. And the setup is relatively simple. I mean, it's just a class and a minimalistic build script that just says, I'm a plugin.
Okay, great, thank you.
And that's all, yeah.
And looking at the time right now, we have time for at least 2 questions. And we got 2 right up front, too. Start here, and saw your hand first.
Is there any investment going to be made to ease migration from other build systems beyond what's already there? I know there's some plugins and some tasks, but I'm really looking, I've got a potential project that would have several hundred builds that have to be migrated, analyzed, compared, verified that they came up with similar or identical results. And I'm just wondering what's on the roadmap to make that kind of process easier?
So I mean, we have the Gradle init, right? So first of all, are you thinking mostly Maven to Gradle?
Mostly, but not exclusively.
Yeah. So we haven't thought at this point, right, about anything else except Maven. So we haven't thought about kind of made to Gradle or anything like that. So our focus is Maven, where we have, I think, the most tedious work is now done by the auto conversion, all the dependency notations, and you know, so the problem are Maven custom plugins usually, right? So we don't have. It's not even clear to us, right? To be honest, what we could do beyond that, right? That would be a game changer, because the basic conversion is now done, right? But how to get auto conversion of Maven custom plugins, I wouldn't know. You know, we could try to have a Maven runtime and, you know, unwrap it with Gradle tasks, but I'm not sure if we want to go down that road, right? So is it for you mostly to basically save the manual conversion step, or is it also to reuse build logic from Maven?
It's more the validation and how do I get
okay.
25 separate teams converting,
Yeah.
feeling like they've got clear guidance on how to convert their builds, because I'm not going to do that for them.
No, that's a good. So what we still have that, right? And you wrote it many years ago, right? There's still a build migration plugin in Gradle, but at the moment, it does what you're asking for different versions of Gradle. You can say run with 3.4 and 3.5, and then show me the diff of the output, right? And that would be. You have some time over the weekend? So it would be basically extending. It was always our idea that at one point we extend that to Maven, and that would make definitely, there would be value in there, that we basically make sure the artifacts you produce are the same, the tests that are run are the same, to get this confidence. So that it's not scheduled yet. Contributions are super welcome, seriously, right? So it would make sense, would be a reasonable feature, absolutely.
I'll just comment quickly that the core team had 4 goals this year, and the 4th one is streamlining Maven migration. I think I've read a whole bunch of ideas in our internal Slack channel, but I know that one of them will certainly be better guides and perhaps some additional init or just better guidance about how to do that. We already have a migrating from Maven guide that we've written recently, so you might check that out if you haven't, and you could probably submit issues directly on that guide as well for ideas.
Yeah, this is certainly something we've done a lot of over the years of managing these kind of migrations, and there's a lot of institutional knowledge we have about doing this that we really should be sharing in terms of processes, which we will do, what Eric was just saying.
And before we run out of time, we've got another question here.
I have a question regarding logging. Eric might know that question. Just want to get maybe an update or something. We would really like to exclude logging from other plugins, and also the debugging output. If we could just get our plugins debug output instead of everything, that would be really cool.
I hear you there, and I know that a lot of others have asked for the very same thing. I can't give you any promises, but it's something that's highly on our radar, especially as we tackle the 3rd goal that we had for 2017, which is streamlining plugin development. That is something that helps essentially build tool teams build better plugins. But other than that, I can't tell you exactly how we'll achieve something like that.
It's funny, we've hit this same issue internally just recently when we wanted to add more logging to help people understand why their tasks aren't being cached. And it's like, well, the only way people are going to be able to find this information is if we log it at info level. But then if every person who has their bit of information makes that same decision, then suddenly info becomes unusable in the same way. So it's certainly something that we've talked about recently, and finding a solution to this is something it's high in our minds anyway.
And we're going to squeeze one more in before we transition over to the keynote.
Thank you. We have this fantastic tool now for building software, testing it, making sure that it's working correctly, packaging it, and storing it. So we've achieved a fantastic state in terms of delivering. But there's another milestone that is pretty important in terms of deploying, actually installing the code that's built, that we can build all kinds of new things. Is this something that Gradle will work more on in the future? Actual installers, I mean, right now we have to use other tools and in many cases replicate the same information that's already available in the build. It knows what libraries, it knows classes, it knows native, it knows, but we need, things like Ansible or Docker or Chef and lots of scripts and things like that. So just curious what your thoughts are on this side of the next frontier, I guess.
So I would say, so I agree with you. We need at least a better bridge into this world. How far this bridge goes, right, on the Gradle side, is still not clear to us. So the way I see it is, the way we will grow that comes from our domain. So integration testing is for me the key domain where we need that as part of the build process, right? So to understand their services, right? They have a life cycle, they have dependencies, and the test picture involves installing and deploying stuff. So that is, we definitely need to come up with a solution, right? I mean, that people don't need to model this from hand like they do right now. I mean, you can do that in Gradle, right? And we have some abstractions around services, but to make that a first-class concept. So that is so in terms of, for integration testing, we need to do a lot of that. And then let's see where this will take us. That's my perspective on that.
Yeah, I would say that my prediction, how I think this is going to play out, is that rather than thinking about a build and then install, we're building more of the install as we go more and more towards containerization and actually creating sort of partitioned runtimes. The job of the build tool or the build process itself is not just to create the software to then go and run somewhere. It actually builds the entire installation, if you like. That's not applicable to all domains, but for a great many, I think that's going to be the trend. So more sophistication going down into the build level as opposed to the deployment level. Deployment becomes something more akin to resource scheduling, as opposed to how do I just move bits and install them on a machine. That's kind of been solved at a higher level, if that makes sense. Lower level, as it were.
Right, so I mean, that solves the server side problem for devices and IoT clients and things. So the question was, that solves the server side problem. What about devices? Yeah.
Yeah, well, yeah. My prediction for what it's worth is that we'll just see the same trend playing out there eventually. More kind of containerized runtimes, which you can also already see in some of the mobile devices.
I mean, when you talk about, if you look, let's say, in the Android world, that build is doing this already there, right? Would you? Yes. Right, yeah, I'm thinking more industrial type. Yeah. Not Android, but yes, you're right. I mean, there's lots of point solutions to this.
And I don't know.
Yeah, but I agree. I mean, it's something. I see definitely your point. So but I think initially it will be a point solution with supported by some abstractions, right, for a specific domain, because it is a lot specific. Oh my goodness, it's too late for that word for me in English. A lot of specific stuff, right? That where it's not clear yet how much can you abstract that.
And I'll invite the panel to throw 30 more seconds on this to kind of wrap it up, and we'll move into the keynote, because I know you've got some closing thoughts here.
Yeah, so I just wanted to say, if we have some kind of abstraction to say, here's how you can deploy this thing, or here install something, then others can jump in and say, actually, I have a tool that can deploy to this IoT device, and I just implement this API. So maybe we don't need to, go the whole way, but just provide some abstraction there. And yeah, I think starting with I need to provision a database or I need to start an application server in order for this test to run, it's probably the right place to start, because that's where the biggest pain is for our core user base.
And on that note, I'd like to thank all the audience for your participation, for your great question. Thank you to our panel. Give them a round of applause, everybody.